Hello and welcome to the 7th in our series of demonstration videos for the VPAT tool. This video will take us through the YTD and projection functions, and we'll demonstrate the basic functionality of each. So we're on the YTD panel right now, and we can see that we have some input, we have some selections on what we're going to summarize. We can filter on time. And what we're going to do here is we're taking historical data that we've got in those daily files that came from those files that came out of the extract process. And we can combine these together. We can pick the level of summarization that we'd like. And VPAT will take the data and produce a daily file that will contain either our average utilization for that day, or we can specify percentiles in here. So if I put 99 in here, we would produce a chart containing the 99th percentile usage for the LPAR or combined KEC in the long-term tracking file. So the point here is to create a file that's easy to use to demonstrate historical data and historical trends. So to do so, we're going to leave it specified at LPAR. We're going to say we don't want to filter on time. Now, we might want to, if we only wanted to pick out our peak intervals, so maybe we want to have 9 a.m. to 11 a.m. is our peak. We want to limit our study to that period. We can actually specify to save only that subset of time so that perhaps we're not distracted by overnight batch usage, and we can actually plot our usage just for our peak periods. We're going to use the entire day for our demonstration here. So when we go and click in the select for the input files here, we're going to click select, and I'm going to navigate us. We're in our demo 2 files, and we have YTD, our subfile, our subfolder we've created. And in here, we have 3 files that we've created on a monthly boundary. We may have used another VPAT function to summarize these and combine these together. But we have 3 months of data here with daily observations in it. And we're going to cancel out of here. So we're actually going to go back and we're going to select our input files, and we're going to select August, and we're going to select it to be included. Now you can put these in any order. It doesn't matter. They don't have to be in sequential order and date order. We could do August and then October, and then we can do September last. So that doesn't matter. And if we have duplicate data, VPAT will simply overlay it. So if we were to process September twice, it wouldn't cause any problems. Again, if we were doing zip growth or other processor growth here, we could individually specify our MIPS here that we want to use. We could select LSPR data from the table as we've seen before, but instead we're just going to let the system have its defaults from what we created in the extract process and the analyze process, where we created that VMIPS file that accommodates if growth occurred on our systems. So here we're going to create an output file. So let's put it in the same location. We're going to do C:, we'll put it in my VPAT folder, and we'll put it in demo 2, and we'll put it in the YTD folder. And this time we're going to call it LPAR dash average. Okay, .YTD. Okay, so once we do this and we click our combine function, that will activate VPAT to summarize this data. Again, here's our VMIPS file that we saw back in the analyze process. So again, if we had different configurations in use during this month, we're reading in the August data now. If we had capacity demand on or off processors, we would see different entries in this table. We could also overlay these, as we've seen before, with LSPR specific MIPS rather than ZPCR MIPS rather than from the defaults from the LSPR tables. We're going to leave this value alone. We get the same display for October, and we'll get the same display for September, and we're going to leave the defaults alone. When we're done, it says, oh, we're going to create a new file. We've created a new file. At this point, this data exists now, and we can simply graph it. So this is our historical usage from August 25th, 2019 through 2 months data, basically. So we can look at this in utilization. So we can see that we've used about peak average at about 80% of our machine. We can switch to MSU views. We can see that our average usage is about 275 MSUs at peak this month. We can see that what our MIPS usage was based on the LSPR data that we left specified. Okay, that's good. So this has created our average data, but it's important to understand that we may want to use some percentile data, and it's important to see the effect of using this. So rather than specifying average here, we're going to actually create a 90th percentile data. Okay, and we're going to put 90 PCTLE here, 90th percentile, and we're going to click the combine button again. Going to leave the default values as they are. And we're going to say, yes, create a new YTD file. And now we've created a 90th percentile chart. So the importance of looking at perhaps upper percentiles is that now when we look at it and we go to MSUs, we can see that we're far above 300 now. We're very close to 350. We're at about 330. So that's been a change, and we can see that by looking at the higher percentile numbers, we can see that this is getting closer to our actual peak usage, which we may want to be aware of. Our peak usage could be approximated by looking at the 99th percentile. Again, we have 96 observations per day from the RMF data on a 15-minute boundary. So 99th percentile is going to be our max. We'll go down here and we'll put in our 99th percentile here, so we properly label our output files. And we'll click on, no, we're not going to click on graph because we haven't combined yet. We're going to combine again. We're going to leave the default MIPS as they were. Going to create a new YTD file, and we've completed it. Now we can graph it. And now if we look at MSUs, we can in fact see that we actually peak at very close to 350, not 330. So this is why it's important to look at percentiles to make sure that we're tracking the absolute top. And to put it into context, we've had at least one interval on this day that used this much time, which means we've had a 15-minute period where our system peaked at that amount. So that's the summary of our YTD functions that allow us to create longer-term tracking. You can add more months to this, more days to this. You can add in however you want, and the system will simply recreate a daily summary of the input data, combining it with the existing YTD data. So you can continue to simply add in November and December and January data as you please, and it will continue to extend the YTD file outward. The last display here is to look at what we can get out of our TFP display. Now, TFP is an alternate pricing model that IBM was using. And TFP says, well, we can take our historical MSU usage and extrapolate it 12 months out. So this is interesting here. Now, we can pick a starting date. We may want to pick a later starting date rather than the start of our data if we've had some growth and we want to simply start tracking from that point forward. So maybe we upgraded and now we have a different growth path, or we've implemented a new application system. But for our demonstration, we're going to start at the very starting date. And we can see now that we've got our historical data plotted here, and we've got at least some squares line plotted against it. So that's the basic functionality of our YTD function. However, the YTD function is directly linked to using the projection function, which is related to capacity planning. So if we click on projection, what we're going to see here is that we can specify a YTD input file. So let's take a look at that 90th percentile YTD file, since we probably want to be aware of what our peak requirements are going to be. And forecasting out, this is another forecasting process. So we can go into here and we can actually select what target machines we want to be on. Now, we knew we were on a 28/27/505 in this example. We saw that in the earlier chart that came up. So we're going to scroll down here and we can simply click on the 506. We can click on the 507. We can click on the 508. And we can actually then say start. And once we say start, we can say start here. And what we didn't do was we didn't select these to be included in our graph. And if we say start at our first date, we can now see our projection of our longer term charting, where we can see at what point our overall growth may intersect with future capacity requirements. So again, this can be aligned with the earlier discussed capacity planning process, and you can actually begin to forecast out at what point in time your percentile-based growth levels, your peak level, or your average usage are going to cross your capacity lines in the future for future capacity decisions. So this brings us to the end of our video showing YTD and projection. Please stay tuned for our last video, which is going to show us a little bit about the simulator functions and the LSPR functions. Thank you very much.